curve has an equation y equals x cubed minus 5x squared plus 5x plus 2. Part A is asking us to find out what the first derivative dy by dx is in terms of x. So here we go and differentiate y to get us 3x squared minus 10x plus 5. We found the gradient function there. That's part A. Part B then goes on to say, find the points P and Q. Well, it says the points P and Q lie on the curve. The gradient of C, i.e. the gradient of the curve at both P and Q is 2. So we're given the gradient is 2. Now, since we have the gradient function, we can see here the gradient is represented by dy by dx. And we know that this gradient is 2, so we're going to go and substitute that in here. So if we go and substitute the gradient 2 in here, so 2 is equal to 3x squared minus 10x plus 5. And that was just by reading line by line maths. And it gives us that the x-coordinate of P is 3. It goes on to then say find the x-coordinate of Q. Well, since we know that the gradient at Q is 2, what we've done is correct. Let's go and solve this then. So make the left-hand side 0. We have 3x squared minus 10x, and since we minus 2 from both sides, we end up with plus 3 here. So we've got our quadratic equation here, and we can then go and factorize this, or we can use our calculator to solve this. So use the equation function on our calculator, polynomial of order 2. The coefficient of x squared is 3. The coefficient of x is minus 10. And the constant term is 3. This then gives us the solutions. X is equal to 3 and x is equal to a third. So we have the x coordinates of both of these. Now in the question it tells us that the x coordinate of P is 3. So this must be the x coordinate of P, and therefore this must be the x coordinate of Q. Part 1 of the question is asking us to find the x coordinate of Q. So let's leave that highlighted. X coordinate of Q is x is equal to a third. So that's part 1. Part 2 of the question. Find an equation for the tangent to the curve at P. So the equation of a tangent, well, we know that a tangent is a straight line. So the equation of a tangent is going to be in the form of y equals mx plus c. I'm just going to just draw a random curve here, and I'm just going to put a point there and draw a tangent there and put the point P here, because that's essentially what I'm looking at. This is my curve C. There's the point P, and I essentially want to find out the equation of this tangent. I know something about this tangent at the point P because we know that the gradient of this tangent is 2. We were given that, so we'll go and write down y is equal to mx plus c. M is 2, so y is equal to 2x plus c. Now we know something about this P coordinate. We know its x value is 3, so I'll write that down, 3, and then the y value, don't know. But I can find out the y value since I have the equation that relates y and x. So let's go and find out what that y value is. Y is equal to 3, which is the x value at P, cubed minus 5, 3 squared, plus 5, lots of 3 plus 2. This gives us 27 minus 45 plus 15 plus 2. 27 minus 45 plus 15 plus 2. That gets us minus 1. So the y value here is minus 1. So let's go and substitute this x and y coordinate into our y equals 2x plus c, which is the equation of the tangent. Minus 1 equals 2 3 plus c, and we can substitute that because that coordinate also lies on that tangent, y equals 2x plus c. This then gives us minus 1 minus 6, which is minus 7, is equal to c. Therefore, the equation of the tangent is y is equal to 2x minus 7. So that's part 2 of the question. Part 3 of the question. If the tangent intersects the coordinate axis at the point R and S, find the length of RS, given our answer in the third form. So, well, let's go and draw an axis here. And we are really interested in essentially the tangent. We know the gradient of the tangent is 2, and its intercepts the y-axis at minus 7, so it looks something like this. It intersects the x-axis here when y is 0. When y is 0, this is 7 over 2. So we've got our intersections drawn here. So what are these coordinates? Well, 7 over 2 is 0, and 0 minus 7. And the question is asking us, well, it's asking us that to find the length RS. Where are R and S? R and S are the points where it intersects the axis. So doesn't tell us which one is which. So let's label that as R. Let's label this one as S. And we want to find the distance between S. So to find the distance, we can use the distance formula, which is essentially, so the length RS is equal to the difference in the x coordinate all squared, so 7 over 2 minus 0 all squared, plus the difference in the y coordinates all squared, which is 0 minus 7 all squared, square rooted. So that gives us 3.5 squared plus 7 squared, which is 245 over 4, all square rooted. Now, if we tidy this up a bit, simplify this third, we want to leave it in the third form here. So root of 245 simplifies to 7 root 5, and root of 4 on the denominator simplifies to 2. So we end up with 7 root 5 over 2 is the length RS.